See all that gray?
Stop it.
It's called depreciation.
Wow. Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're recording from my house again with my lovely, talented, and very pregnant wife, Kristi. She's holding the camera.
Hi.
Yeah, great job. Thanks. Now, today we're going to be talking about modeling real-life situations with exponential functions. Okay. I love exponential functions. It is by far the most useful unit that you'll do in Algebra 1 because everything is exponential. And we'll start to see that today. And hopefully you can begin to use some of these ideas in your real life to help you make good choices. Okay, before we're going to begin modeling actual situations, let's remember the equation for a exponential function. It's a times b to the x. Just like when we're graphing, it's the exact same function and things mean the same amount. I told you last time that a represented the starting value. That's going to be really important here. And b is still the multiplier. Okay, so keep those in your head as we go today. If you don't have these in your notes, get them in your notes now. All right, so we're going to look at a situation here. One of the most normal things that we begin with is you look at things that double over time. So one of the most obvious things is bacteria. Bacteria reproduce by splitting, and so you can actually model the population of bacteria with exponentials really well. So let's imagine we have 1,000 bacteria in a culture. I want to know how many bacteria are going to be there if they double every hour after 10 hours. Let's see what happens. Okay, so I've got a culture of 1,000 bacteria, and it doubles every hour. So the nice thing about exponential functions is there's not that much to plug in. It's pretty obvious that 1,000 is your starting value. And if you're doubling something, we suppose the multiplier would be
2.
Yeah, exactly. So it's actually pretty easy to write an equation for this. So y equals 1,000 times 2 to the x. Sometimes I use parentheses here just to make sure that it's its own thing, but you can use the multiplication symbol if you prefer. It doesn't matter. Okay, so we can go ahead and do this. I'd highly recommend if you are going to do this, use a calculator. Okay, so if you want to find an answer, you want to plug this into your calculator. It's pretty easy. Just remember that your exponent button is right here above division. And so you can choose whatever we want. So maybe I don't want to know 10 hours right away. I want to know what 5 is. Let's see what happens if I double this 5 times. Maybe right now you can kind of guess how many you think it would be. There you go. Can you see it now? Cool. Do you have a guess?
No, don't put me on the spot.
Okay.
Remember, million.
Okay. So remember when we're looking at a million. That's not a bad guess, actually. So remember, your brain is going to lie to you about your intuition on how big things get with exponentials. So if you're guessing low, think bigger.
So far off.
Okay.
If you gave me time, I would have gotten it.
Yeah, that's good. Okay. Because remember, we started with 1,000 and it's up to 32,000. Only took 5 hours. Okay, so a lot of people look at this 2 and the 5 and they see a 10. They'll be like, oh, it's 10,000. But it's not. It's actually 32,000 because that's 2 times 2 times 2 5 times. And then you multiply that by 1,000. So after 5 hours, we can make a table if you want to. A lot of times it's helpful to put in hours and then number of bacteria. So we know after 5, we've got 32,000. Any guesses on how many will be there after 10 hours? What do you think?
Oh, you're asking me.
Yeah, I'm asking you again.
I'm the only one here.
Yeah, exactly. It's weird how that works.
2, 4, 6, 8. So another times 10. Oh my gosh.
That's okay. I want you guys to guess on your own.
I think it's going to double every time.
All right.
Right?
So let's see what we can come up with.
Right?
It is, yes.
Okay. But it won't double there. It'll double 6, 7, 8, 9, 10. So it will be quintuple by the.
Yeah, it's not. So a lot of people would say, "Oh, it's 32,000. This would be 64," but it's
No,
actually going to be 64
64 at the 6.
At the 6. Very good.
Yeah.
Okay. So a cool trick, if you want to just retype something in your calculator really quickly, hit the second button, and then enter. It says entry, so it's going to retype in what you just did, and then you can just use an arrow key and change that exponent. Yeah, it's a lot bigger. Okay, it's not 64,000.
Hey,
it is.
It's a million.
It's a million. Great
Look
guess.
At me.
Good job.
It's close, but not really.
Okay, so it's going to be a million after
10
hours. Yeah. So these grow really quickly, which is why you get sick, and it takes about a day before you're going to get sick from bacterial poisoning. Okay, so that's our first example. But again, I want you to take a look here. Look for the multiplier. Look for the starting value. Plug it into your equation. Use your calculator. I'm not expecting anybody to be doing this by hand. Okay, so let's look at another one.
You expected me to do it in my head.
I did, because I'm mean. All right. So the next one we're going to take a look at is going to show you another way that you can use exponential functions. It's a little bit more useful than finding the number of bacteria. So let's imagine you have gone to college and you listened to Calbeck. You did really good on your math and you got a great job. You got $50,000 a year right out of college, and your boss says, "Hey, if you keep doing a good job, we're going to give you an 8% raise every year."
Wow.
Sounds nice.
Yeah.
Now, that doesn't sound initially like an exponential function, but it is, because it's 8% every single year, and that 8% builds on itself. So you're making $50K a year. Woohoo! And you got 8% every year on top of that. Okay? And so we want to plug this in, and it's pretty obvious that your starting value is going to be 50,000. That's what your beginning salary is going to be. The question is, how do we use a multiplier when it's 8%?
0.08.
0.08. Let's see what happens if we plug in 0.08. Okay, that is 8% as a decimal. So let's see what happens.
Uh-oh.
So I'm going to multiply by 0.08. So you'd think that's going to go up a little bit, right?
No, it's going to be a small number. Yeah, because you'll get $4,000 as a raise. Yay!
So I got to figure out a way.
54,000.
Okay, you're right. It would be 54,000 because I need to add this 4,000 to my original amount. So I need the original amount. And I'm not getting that too. So I got to figure out a way to get this
I see.
0.08 and the original amount together. So the way that I do that is kind of sneaky, because I can get the raise with this part. So what can I multiply 50,000 by to keep 50,000 exactly?
1.
By 1. So let's put them together. Instead of doing 0.08, which gives me a lower number, or 1, which gives me the same, let's make it 50,000 times 1 plus 0.08.
Wow.
Okay? So I'm increasing by my original amount, that's the 1, by 8%. And that goes to the x power.
Look at that.
And let's see if that works. So let's do 50,000 times 1.08. And it does give us 54,000. Okay, so that's awesome. So let's see how much you're going to have after 5 years of working at this company.
Oh.
Let's find out. We're going to put 5 in here. You guys can do this on your own if you've got a calculator. I'm going to use my trick here, second entry, and then use a little exponent with a 5 here. And we're going to see how much we've got after 5 years. Oops.
Oops. Enter.
Okay,
Okay.
$73,000. That's a pretty good salary.
After 5 years, yeah.
Okay. What do you think after 10? What do you think?
A lot more than that.
Are we going to be at 100,000 or not?
Yeah.
You think we're going to be at 100,000?
Yeah.
Let's find out.
Look at
100,000.
that.
Nice
Told
job.
ya.
And you're starting to build that intuition. So after 100 or after 10 years, you're going to be making 6 figures at this particular company. And don't forget your 25 cents. Okay? So really important there. But again, we can actually use percentages in our exponential function. And the way that it works is this. Your multiplier, when you're using a percentage, is going to be 1 plus the rate, whatever it is. Okay? And your rate is always going to be a decimal.
Mm-hmm.
Okay, so it's not a percentage, but you need to change to a decimal. All right, let's do one more here. Different situation with the percentage. You bought a new car.
Oh.
You followed one of those COVID deals, and you're like, oh, but they gave me so much cash back. It's such a good deal. And you get the car, and you're really excited, and you find out that your new car is now losing 23% of its value every single year. And that makes you sad.
Every year?
Yeah.
Boy.
Yeah, that's not good. Okay, so your car costs $20,000, and you're going to be losing 23% of its value every year. Okay? So this is another percentage situation, just like we had before. The only difference is it's going down. Okay, so any thoughts about how we could combine what we've talked about before with percentages with something that is going down?
Is it 1 minus then the percentage as a decimal? So
Gosh.
1 minus 0.23?
That is fantastic. Great job. Great job. I don't know if you guys
Thank
heard
you.
that because she's talking to the camera, but when you're losing money, instead of doing 1 plus the rate, you can do 1 minus the rate because you are losing that amount each year or each whatever month, whatever unit of time you're looking at. Okay? And remember what we had before. We had the original amount plus the increase. So now we have the original amount minus the decrease. Okay? So it's going down that much. So when I set it up, I've got 20,000 as my starting value. So I got 20,000. And this one is going to be 1 minus 23 as a percentage. It's 0.23 to the x power. How much do you think your car is going to be worth after 5 years? Shall we try that? What do you think?
Not much.
Not much?
Not that much. Let's see, 23% is pretty significant.
That is a lot.
5. What?
Yeah, your
only
car's going to be
worth
worth $5,000 after 5 years.
Goodness.
Okay? It depends on the car, but this is not an abnormal amount of
Depreciation.
That's the word I was just about to teach them. Okay? When things are increasing, it's appreciation. Decreasing is depreciation, when things become less valuable over time. Okay?
See all that gray?
Stop it.
It's called depreciation.
Wow.
See all that gray?
Stop it.
It's called depreciation. Like,
Yeah,
and
don't.
thumbs up.
Yes. If you
subscribe.
Yeah, right. If you like my wife making fun of me, go ahead, leave a comment for her.